Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Detonation sensor, DS, transmits a signal of detonation to the electronic control unit, ECU. The ECU responds by reducing the ignition advance angle and enriching the fuel-air mixture of the engine. In essence, the detonation sensor is responsible for the timely detection of detonation of the mixture. Now you know what the detonation sensor is for. Detonation in the engine is an explosion of the fuel-air mixture. There can be several reasons for this for a gasoline engine. Here are some of them: low-octane fuel, depleted fuel-air mixture, too early ignition, a thick layer of carbon deposits in the combustion chambers, which increases the compression ratio of the engine. The consequences of prolonged exposure of the engine to this process are most often broken partitions between the ring grooves on the pistons. This, in turn, leads to a drop in compression and the formation of scoring on the cylinder mirror. These faults are eliminated by repairing the cylinder piston group of the engine, that is, boring and honing of cylinders, as well as replacement of pistons and rings. From this it becomes clear why detonation should be quenched. Determine the presence of detonation in the engine can be determined by characteristic rattling metallic sounds, which many drivers confuse with the knocking of fingers in the connecting rod. Principle of operation. The operation of the device is based on the property of plates made of materials called piezoelectrics to convert the mechanical energy of the pressure applied to them into a potential difference between their opposite sides. Such a sensor consists of a housing with elements of attachment to the motor, and a piezoelectric plate inside with terminals connected to its opposite ends. The plate deforms under the influence of sound vibrations during detonation and converts the energy of mechanical vibrations into electrical impulses of appropriate frequency and amplitude. Faults are most often associated with broken leads inside the housing. Despite the apparent simplicity of the defect, no one tries to repair the sensor, preferring repair to replacement. Varieties. The detonation sensor can be either resonant, in the form of a cylinder with one contact on top, or broadband, similar to a thick washer with a 2-pin connector. The broadband detonation sensor converts all engine noise into electrical vibrations and transmits them to the ECU for recognition and decision-making. The resonant one is tuned to the detonation frequency of the engine and gives a signal only when the noise frequency coincides with its resonant frequency. Note that wideband sensors are not interchangeable with resonant sensors, even if they are made by the same company. Detonation sensor design, Mazda 3, signs of DD defect: high fuel consumption, intermittent detonation, activation of check engine indicator. On the instrument panel, poor fuel economy, reduced engine power, increased exhaust smoke. Ways to check the detonation sensor. If the ECU is designed to provide the reference voltage to the sensor, use a voltmeter to make sure that it reaches the sensor. Absence of reference voltage on its terminal will indicate that the fault is not in it, but in the wiring or in the ECU reference voltage generator. Lack of reference voltage will be perceived by the controller as a fault of DD and will turn on the emergency mode of operation. In case of wiring failure, the impulses generated by the device will not reach the ECU, because the same wire is used for their transmission as for the reference voltage supply. The result will be little different from the previous case. Measuring the electrical resistance of the DD. But in order to draw a conclusion about the presence or absence of a fault, it is necessary to know what resistance it should have. Control of the ability to generate electrical impulses in response to sound impact. Connect to the output of the removed device voltmeter in the AC voltage measurement mode with a measurement limit of 200 MV and lightly tap it with a screwdriver. Voltmeter should show the appearance of electrical voltage. If the reading remains zero, it is very likely that the sensor is faulty. Calculating motor resonance if your car's motor is equipped with a resonance sensor that has failed, and for some reason you want to replace it with a sensor of another model, you need to know the resonant frequency of your engine. It can be calculated using an empirical formula, res equals 900 pi r, where pi, 314 r, piston radius in millimeters, the result will be in kHz. For example, for a power unit with a piston diameter of 82 millimeters, F res equals 900, 3.14 by 41 equals 6.99083 kHz, or after rounding 6 and 991 kHz. In conclusion, we have explored the key aspects of detonation sensors, addressing common questions and clarifying their functionality, applications, and importance in various fields. Understanding these sensors not only enhances our knowledge of safety measures but also highlights their role in advancing technology. If you have any further questions or need more information, feel free to reach out. Thank you for watching, and stay informed.